So we've seen this list before. This is a list of all the common Taylor series. In this video, I'm going to show you how the list was created. We're just going to look at inverse tan of x. You could, if you want to, come up with this series yourself for all of these. But all this should be revision. You should already know this. So I'm just going to whiz through it. So to come up with this series, for inverse tan of x, we would start out with a function equals inverse tan of x, and then we would start out with the general series, and then differentiate this, and then we would then differentiate this, and then we'll differentiate this. We would then demand the first derivative of this to match up the first derivative of this. We would demand the second derivative of this to match up the second derivative of this, and so on, all the way to infinity. And we would also demand that the original function to match up with the original over here. So at x equals 0, you would put 0 into here, so that would be tan, inverse tan of 0. So inverse tan of 0, well, tan looks like this, inverse tan looks like this. So inverse tan of 0 will be 0. This whole thing here will be 0. When you put 0 into the x here, because at x equals 0, we will put 0 into the x here. This thing here will be 0. It disappears. So a0 equals 0. That's why your series looks like this. So you've got your inverse tan of x. The first, that's why a0 is 0. So hang on, a0 is 0. That's why it starts at x here. So the first one starts at x. That's why you don't have a constant. So because the constant is 0. And then for the second term, we would differentiate this. We would then differentiate this, and then demand that the first derivative of this match up with the first derivative of this. So at x equals 0, you would put 0 into here. So this thing here would be 0. So the whole thing here would be 1. And then if you put x equals 0, if you put 0 into here, this thing here will be 0. This thing here will be 0. So a1 is equal to this thing here over here, which is 1. So a1 here is equal to 1. So if you look at this here, a1 here is equal to 1. So 1 times x. So the first term will be x. That's why you've got this x here. Let's look at the second one. So we would demand the second derivative to match up with the second derivative over here. So at x equals 0, hang on, let me check something. Yeah, okay. At x equals 0, you would put 0 into here. So this whole thing here would be 0. Well, put 0 into here. Then this would be negative 2 times 0. That would be 0. 0 over blah blah blah. This whole thing here will be 0. So now put x equals 0. Put 0 into here. So this thing here will disappear. Everything else thereafter will also disappear. All that you're left with is 2a2 equals 0. So a2 must equal 0. So looking at this, a2 must equal 0. That's why when you look at inverse tan, you don't have an x squared. The next one will be x to the power of 3. So to get the next one, you would differentiate this again, and then tidy this up. That will then give you this. So at hang on, let me think. Yeah, so differentiate this. That will then give you this, and then we would demand that this to be the same as this. So we would demand this thing to be the same as this, which is this thing to be the same as this thing here. So hang on. So at x equals 0, you would put 0 into here. So let me think. When you put 0 into here, so this thing here would be 0 plus 1. That would be 1. So this whole thing, this bubble here will be 1. This bubble here will be 1. 1 squared, because of this square here, will be 1. And then this thing here times 1, blah blah blah, take my word for it. When you put x equals 0 into here, this whole thing here will be -2, and then when you put x equals 0 into here, then this thing here disappears, everything thereafter will disappear, all that's left will be this. So that will then be this. So now it's just a matter of finding A3. Well, A3 is -1/3. So going back to here, A3 here is -1/3. So that's why when you look at this, you've got -1/3 x to the power 3, x to the power 3, and so on. The point of this video is to show you that you can come up with all these yourself if you wanted to. Okay, yeah. Okay, so